Let's suppose we have the data set consisting of the values 1, 2, 3, 4, and 5. In order to find the mean for this set, we would add up all of those x values and then divide by the number of data values that we have. So that would just be 1 plus 2 plus 3 plus 4 plus 5 divided by 5, which we could rewrite a little bit. And for the purposes of what we're going to study next, I'm going to do this in a little bit different way than we have been before. I'm going to factor out a 1/5. And what we'll have left is 1/5 times 1 plus 2 plus 3 plus 4 plus 5. And this may seem an odd thing to do at this point, but it is going to have a purpose here in just a little bit. So these two things are the same. Multiplying by 1/5 is the same as dividing by 5. And then I could distribute this 1/5 through here, and what I would have is 1/5 times 1 plus 1/5 times 2 plus 1/5 times 3 plus 1/5 times 4 plus 1/5 times 5. And this is going to give me, just in the same way that I would add all these up and divide by 5, I'm still going to get 3. We have 15 over 5, which is 3, or 1/5 plus 2/5 plus 3/5 plus 4/5 plus 5/5 is 15/5, which is 3. Now let's suppose that we add some more values to that set. So instead of just one value of 1, we have 5 of them. And we have 2 2s and 4 3s, 2 4s, and 2 5s. So we'll do the same thing. We'll factor out a 1/15 this time because there's 15 data values. And that'll leave us with then now really what this would be then is 1/15 times 5 times 1 plus 2 times 2 5/15 times 1 plus 2/15 times 2 plus 4/15 times 3 plus 2/15 times 4 plus 2/15 times 5. Now the whole point here is that 1 has a larger multiplier than 2 or 3 or 4 or 5. So this value of 1 is contributing more to this mean than these other values. 3 is the next most frequent data value, and so it is contributing more to this mean than 2 or 4 or 5. This mean turns out to be 2.6. So less than what we found before, 3, and that is because this data set became heavier towards the bottom of its range than it did towards the top. So if we were to think about this kind of like a balance, so we've got this beam that has a balance point, and if we have 1, 2, 3, 4, and 5, like we did in that first set, then it would balance right in the middle, right at the 3. But if we start to stack the 1s, then it would change. Let's look what happens here. So let's put another row of each of these numbers. We're still balanced in the middle. Now our other data set, the second data set, had 2 2s, 2 4s, and 2 5s. But it had 5 1s and 4 3s. So now I'm going to add a 1 and a 3 on here, and that starts to move that balance point to the left. I'm going to add another 1 and another 3. So now I've got 4 1s and 4 3s, and that balance point is still moving to the left. And then when I add another 1, it moves even a little bit farther to the left. So in order to balance that data set, instead of being at 3, we're now at 2.6. So this is the notion of what's called a weighted mean, when some values contribute more to the mean of a data set than others do. And the formula for this is the sum of the products of the weights and the data values divided by the sum of the weights.